question 48 on the homework, right? We're asked to find the delta H for the thermite reaction. 2 aluminum react with iron 3 oxide to produce aluminum oxide and iron. Right, so they give us the 2 half reactions. They tell us that iron solid goes to iron liquid. And they tell us that delta H is 13.8 kilojoules per mole. And they tell us that the second reaction they have is aluminum solid, right, goes or plus 1/2 iron 2 oxide. So there was a typo. I did edit it on some of the homework. So they had Fe2O2. That obviously was wrong. It should be Fe2O3. You're never going to get those two to cancel out. And then that gives us 1/2 of aluminum oxide and liquid iron. And the delta H for that is negative 118.6 kilojoules per mole. So just like before, we want to try to flip these 2 reactions, right? Ultimately, the reaction we're looking for, I did drop the phase, but we are looking for a solid iron. Aluminum oxide is solid, iron 3 oxide is solid, aluminum is solid, right? So that's a solid there. Again, I would just see, okay, I want iron solid as a product. I have iron solid as a product here. I need one more coefficient, right? So I'm just going to multiply the whole thing by 2. So multiplying that whole thing by 2, bring that down here, I get 2 moles of iron solid. Or sorry, I want to flip that too. Yeah, we want to flip that because we're looking for a solid in our reactant. So we're going to flip that because we want iron solid. So I get 2 iron liquid goes to 2 iron solid. So our delta H, we flip that and we multiply by 2, so 26. So what's that? 27.6, yeah, negative 27.6 kilojoules, because I had to flip the sign and then multiply delta H by 2. The next one, right? What do we have to do with the next one to get the reaction we're looking for? Yeah, multiply by 2. Yeah, just multiply by 2. Aluminum's in the right place, right? So multiply that by 2. I get 2 aluminums. I get a whole iron 3 oxide. I get a whole aluminum oxide, and I get 2 liquid iron. Plus, right? Iron cancels out, liquid iron cancels out, I should say. Add those 2 together, we get the reaction we're looking for. We've got 2 aluminum, iron 3 oxide, aluminum oxide, and 2 iron solid. The liquid iron canceled out. Multiplied that delta H by 2. .2. Add those 2 together. Right, plus 26, and I get 264.8. Someone hit the lights, but maybe not. For that reaction, I would say, because of that, the 1 decimal place in each of those, when we add those together, we're still going to have 1 decimal place. So I would say 2 significant or 4 significant figures. 264. Oh, yeah, sorry. Got dark in here. I thought everyone was gonna like jump me and try to take the exam, getting nervous. Yeah, 264 minus 264.8 kilojoules. For that, I would say 4 significant figures because again, addition and subtraction, you go to the decimal places, they both have a decimal place. So we should have a decimal place in the final answer. Yeah.
And these questions when covered on what you do.
Yeah, we, is there anything else from the homework we want to take a look at?
33.
33 in the homework.
I have one. For the second change in enthalpy, why didn't we switch it if we're going from liquid to solid?
And the second one, we didn't need to switch it because I want aluminum as a reactant. I want the iron 3 oxide as a reactant. So I want these on this side already. We got rid of, it makes liquid iron in this reaction, but we're gonna get rid of the liquid iron from the first one here. It's gonna cancel out. So we're actually gonna make the solid iron. We're gonna get the solid from that first reaction. We're not gonna get it from this reaction. Okay. Like we need these on opposite sides because basically this is saying like, if you want to think about this reaction first, if you want to think about these reactions in sequence, if I did this reaction first, I make that liquid iron. I put that liquid iron into the second reaction and it comes out as solid iron. And that's our overall reaction. It might be easier if I had written this on top to kind of think about, okay, we go through this process. I make this. And then it doesn't end up in the final equation because in this process, I take the liquid iron and we go to solid iron. And so it doesn't end up in the final reaction, right? It goes in and turns into, it comes out of one reaction, goes into the next reaction. So it's like an intermediate, right? Like
There's only like one reaction.
yeah, okay. So we're adding these two together. I know this energy, I know this energy, I'm looking for this. I want to see what the energy is going to be like. What would the energy be if I just did one big reaction instead of two separate reactions? So ultimately, yeah, this is made, but it goes in up here and then comes out solid iron. So it doesn't end up in the final reaction, it's gone. Yeah, Hunter.
How do you know how many like stick fixtures in any given body? Like how many stick fixtures?
So number one, the exam will be easier because the exam's like all multiple choice, right? So it's going to be there for you as the correct number of